जस्ट अ क्विक रिवीजन ताकि हमें अंदाजा हो कि प्रेशर प्रिज्म क्या है. बेसिकली फॉर प्रेशर प्रिज्म हमने क्या किया था, we start, let's say we have a tank and discussed, okay ji, we want to draw a graphical representation of the pressure forces acting on the wall of this tank. We took one wall, let's say the right wall, and we just draw, okay, we said, okay, this is the pressure distribution. If this is H is representing the elevation of the tank. At this point, pressure is 0, and at the bottom it is equal to gamma H, because this fluid has value gamma as its specific weight, and this H is the elevation of the tank. We are interested in calculating the resultant force and its location. So we concluded that the resultant force Fr here, that would be equal to the Fr किसके इक्वल होगी,
rho HA, rho HCA,
rho HCA or the volume of the pressure prism. ऐसा ही था. And here that is equal to the volume of this prism, that is equal to half, that is 0.5 base, which is gamma H, H C into the area. ठीक है. This should be equal to gamma HCA, and that is equal to basically 0.5 of the base, which is this gamma into H into again H, which is the height, and into the thickness, which is B. ठीक है. So B into H is area, and 0.5 of H is HC. Right? Clear है?
सर ये आप तो लिख रहे हैं बहुत छोटा नजर आ रहा है, थोड़ा जूम कर सकते हैं?
ये इसको हम जूम कर देते हैं. अभी ठीक नजर आ रहा है?
यस सर.
So gamma HCA is the regular formula, but area and volume of this triangle or prism is the formula which is we are going to use for calculating through graphs. ठीक है? And then we are interested in the location of this force, which is, let's say, y, where this force will act. So we said y will be equal to centroid of this pressure prism. For triangle, this is usually, because prism is triangular, this is usually h by 3 from the base. This y from base would be h by 3, or from top it would be equal to 2h by 3. Okay, is it clear? Is it clear? आवाज आ रही है जी मेरी आप लोगों को?
सही
सर आ रही है.
सही x इक्वल टू क्या लिखा है सर, प्लीज बता दें.
Y equals to centroid of this prism, centroid of,
ये लोकेशन है FR की.
yes, it's the location of the FR.
ठीक है सर.
ट्रायंगल फिगर में मैंने जो है वो मार्क कर दिया इसको. सो फिर हमने इसकी डिफरेंट वेरिएशन डिस्कस की लास्ट लेक्चर के अंदर ही, और डिफरेंट तरह की फॉर्म्स में डिस्कस किया कि अगर फ्लूइड के ऊपर ओपन सरफेस नहीं है, प्रेशर है, फिर क्या होगा. अगर ऑयल का टैंक है, डिफरेंट फ्लूइड्स हैं कंटेनर के अंदर, फिर किस तरह से होगा. तो एंड वी सॉल्व एन एग्जांपल रिलेटेड दैट. आज एक एग्जांपल और सॉल्व करते हैं इसी से रिलेटेड, एंड देन वी विल क्लोज दिस टॉपिक एंड मूव ऑन टू द नेक्स्ट टॉपिक. ठीक है. सो टुडे वी हैव the problem. We have an open rectangular tank which is 2 meter wide and 4 meter long. The tank contains water to a depth of 2 meter and oil of specific gravity 0.8 on the top of the water to a depth of 1 meter. Determine the magnitude and location of the resultant fluid force acting on one end of the tank. What we need to do is we have this tank. Which is 2 meter wide which means that its depth into the page is 2 meter. Okay. This 3-dimensional cross section is basically 2 meters, just like this. And it is 4 meters long. This dimension is 4 meters. The tank contains water to a depth of 2 meters. That means we have water from this point to this point. We fill it with water. Here we have water, and on top of water we have an oil of specific gravity 0.8 till a depth of 1 meters. That is means we have oil depth of 1 meter. Let's color it. This is the oil having specific gravity 0.8. So this is oil with specific gravity of 0.8, and this is water. This height of the water is 2 meters, and this height of the oil is 1 meter. We are interested in calculating the resultant force and its location. Now, simply using gamma HCA and the formulas for YR and XR is difficult in this case. So we'll try to solve it using the concept of pressure prism. So I draw the wall of the tank here. Starting from the free surface, that is where we have oil, from this point, we need to move to the bottom of the tank, which is 3 meters. So this elevation on the wall is basically, this is 3 meters. And this point indicates 1 meter. We are interested in drawing the pressure prism. So how the pressure will vary? It will vary from 0 at the top till 1 meter. We'll have some triangle like this. This is the 1 meter line. And then after that, because the fluid is changing, so the triangle will change its shapes and the pressure will be something like this. So from 0 to this maximum value. So the pressure prism is something like these two triangles. Clear? इसी तरह का pressure prism बनेगा जी. This side being 1 meter, this being 2 meter. ठीक है, समझ आ गई pressure prism कैसा बनेगा? ऐसे ही बनेगा. So we'll have pressure variation like this here, and we'll pressure variation like this here, and pressure variation here like some of these pressures. So the dimensions now and the resultant forces. Is it clear?
Yes, sir.
Okay, the base dimensions. जो base पे मैंने dimensions ड्रॉ की हैं pressure prism पे, क्या ये बता सकते हैं आप लोग? This is dimension 1. Let's say this is dimension 1. What it would be equal to, and the dimension 2. जी dimension 1 और 2 बता सकते हैं आप? We'll have basically 3 forces. One in this pressure prism as this red one as F1, then F2 here in the rectangle, and then F3 again in this third triangle. So the resultant force would be sum of these 3 forces. Fr would be equal to F1 plus F2 plus F3. So we are interested in calculating the location of FR and the FR itself. For that, we need to calculate F1, F2, F3 and its location, Y1, Y2 and Y3. Okay. So F1 would be equal to the
mu of oil H1 और ये पहला एरिया बनेगा और पहली.
So F1 equals to the volume of the first prism. ऐसा ही है?
Yes sir.
क्या है वॉल्यूम फर्स्ट प्रिज्म की, जी बता सकते हैं?
Sir, half into specific weight of oil.
The base of the triangle, which is 0.5, multiplied by the
Specific weight of oil.
weight of oil. Let's write it as gamma oil.
So multiplied by height square, which is 1 square.
Which is H1 multiply. This is the half base into height. Again H1, right?
Yes sir.
Into the depth. That
2
is
meters.
width. This tank, which is 2 meters. ठीक है? समझ आ गई बात?
Yes sir.
So F1 equals to 0.5 multiplied by gamma, which is 0.8, because specific gravity multiplied by the specific weight of the water, which is 9.81 kilonewtons per meter cube. Multiply by H1, which is 1, multiply by again H1, which is 1, and then multiply it with 2. Clear? So F1 is, क्या वैल्यू आएगी F1 की? 0.5 multiplied by 0.8 multiplied by 9.81 multiplied by 2, which is 7.848, which we can write it as 7.85 kilo newtons. ठीक है? क्लियर है?
जी सर. किलो न्यूटन क्यों लिखा?
क्योंकि मैंने यूनिट्स क्या यूज किए हैं स्पेसिफिक वेट की,
Okay.
गैमा ऑफ वाटर. ठीक है? हियर वी हैव गैमा ऑफ ऑयल, तो उसके लिए मैंने फिर right. Now what about Y1? Let's say Y1, location of the force 1. This is equal to
So 2 by 3 of H.
centroid of the first prism, and we are measuring it from the top, ठीक है? From O. So it is equal to 2H1 divided by 3. ऐसे ही है? ठीक है? So it is equal to 2 by 3. That is 0.67. Because H1 is 1 meters, right? Any question in that? इसके अंदर कोई चीज समझ ना आई हो?
No sir.
For F2, this is equal to, for F2, this is equal to the volume of the second prism, which is a, in 2 dimension, which is a rectangle. ठीक है? So this is equal to, जी किसके इक्वल होगा? एरिया ऑफ दिस रेक्टेंगल क्या है? मल्टीप्लाई बाय डेप्थ. ठीक है? ऐसे ही होगा. एरिया ऑफ रेक्टेंगल इनटू डेप्थ, right? F2 equals to the area of this rectangle, and the dimension 1 is equal to the this dimension of the triangle, which is equal to the gamma oil into H1. So we'll write here oil H1 multiply by H2 is the area of the rectangle into depth, which is 2 meters, right? Is that right? ठीक है, समझ आ गई बात? So gamma of oil is 0.8 into gamma of water, which is 9.81 into H1, which is 1, multiply by H2, which is 2, multiply by the final. So F2 equals to 0.8 multiply by 9.81 into 2 into 2, 31.4 kilonewtons. ठीक है, 31.4 kilonewtons. And the location of Y2 is, the Y2 location is centroid of the second prism. Basically, the second prism is
rectangle.
angle, and the centroid would be equal to H2 by 2. ऐसा ही है.
Yes, sir.
प्लस इसमें क्या करेंगे 1. क्यों? क्योंकि हम रेफरेंस कहाँ प्लेस कर रहे हैं, मेजरमेंट रेफरेंस टॉप पे. ठीक है, समझ आ रही है बात?
जी सर.
हमें किसी रेफरेंस से मेजर करना है तो सेंट्रोइड ऑफ द रेक्टेंगल तो h2 by 2 होगा, बट उस रेफरेंस से डिस्टेंस कितना होगा उस सोर्स का, दैट इज y2. ठीक है, तो दैट्स व्हाई वी आर एडिंग 1 टू गो टू रेफरेंस, so it would be equal to 2. समझ आ गई बात? सही है.
सर ये गैमा ऑफ ऑयल किस तरह निकाला है सर आपने?
गैमा ऑफ ऑयल क्या होता है जी? अब तक हम कितनी बार पढ़ चुके हैं ये चीज.
सर डेंसिटी डिवाइड बाय डेंसिटी ऑफ,
we are not given gamma of the oil, we are given specific gravity of the oil, which is 0.8. ठीक है, and earlier from the first chapter, from the first week, we have studied specific gravity equals to density of the oil and density of the fluid. इस case में oil है divided by density of water, and if we multiply and divide it by gravity, it will become specific weight of oil divided by specific weight of water. So if we know specific weight of water and specific gravity, तो we can calculate the specific weight of the oil. तो ये हमारे पास calculate हो जाएगा. ठीक है?
Yes sir.
So we are multiplying 0.8 by 9.81, which is specific weight of the water. Clear? F2 clear होगी? इसमें कोई क्वेश्चन हो? F2 की कैलकुलेशन में कोई क्वेश्चन तो नहीं है?
No sir.
Finally, F3. F3 is volume of the third prism, which is equal to the area of triangle multiply by the depth into the page. So F3 equals to area of triangle क्या है जी? Half base into height. Base is this dimension 2, which is equal to, yes, किसके इक्वल होगी ये? बेस किसके इक्वल होगी?
Sir half
Yes,
multiplied by gamma of water
multiply by gamma of water, right, into
H2.
yes, right, H2. This is the base multiply by the height, which is again H2 multiply by the depth, which is 2 meters. ठीक है, समझ आ गया F3 का फॉर्मूला कैसे डिजाइन कर रहे हैं? ठीक है, so F2 is equal to 0.5 multiplied by 9.81, which is gamma of water. H2 is 2, again H2 into 2, 39.2. ठीक है, so F3 is 39.2 kilonewtons. Y3, is equal to the centroid of this prism, which is equals to 2h by 3 from the top. So 2h2 divided by 3. And again, because we are measuring from the top, but this is just of the triangle, so we need to add the dimension 1 so that it is the right value, it is the right reference. This is equal to 2 into 2 divided by 3 plus 1 to 2.33 meters. Clear? Is it clear?
Yes, sir.
Now the resultant force. Resultant force is simply the sum of these three. So we write the resultant force here. R equal to F1 plus F2 plus F3 equal to 7.85 plus 31.4 plus 39.2. So FR is 7.85 plus 31.4 plus 39.2, 78.45. It is almost equal to 78.5 kilo newtons. Clear? YR. जी YR कैसे कैलकुलेट करेंगे? जी YR कैसे कैलकुलेट करते हैं फॉर प्रेशर प्रिज्म? आवाज आ रही है जी आप लोगों को?
जी सर, आ रही है आवाज।
फिर जवाब क्यों नहीं देते? YR कैसे कैलकुलेट होगा?
सर ऐड करने से तीन होगा, y1 y2 y3।
नो, वो तो प्रेशर प्रिज्म से बाहर की कोई डायमेंशन बन जाएगी। FR should act somewhere between the resultant of these F1, F2 and F3. ऐसा ही है? Y1, Y2 and Y3 के बीच की कोई वैल्यू होनी चाहिए। How do we calculate? If we have three forces, we know their magnitude, we know their location. We have a fourth force whose magnitude is known but location is not known. So dynamics के अंदर कैसे करेंगे? And the fourth force is the resultant of the three forces. Mechanics के अंदर, statics के अंदर ये calculate कैसे करेंगे location आप?
जरा फिर से बताएं सर, क्या कहते हैं?
Sir, F1
We have done this in the last
F1
class.
into Y1 plus F2 into
जी तो जो basically we have three forces whose magnitude is known, whose location is known. We have a fourth force which is resultant of these three forces but its location is unknown.
Y2 plus F3 into 2 plus Y3.
तो ये क्या करेंगे हम? Basically क्या कर रहे हैं?
Sum, sir, resultant moment is equal to sum of individual
The
moments.
moment of the individual forces. ऐसे ही है? So I'm writing F1 Y1 plus F2 Y2 plus F3 Y3 divided by FR. ठीक है? फॉर्मूला ठीक लिख दिया मैंने? ठीक है फॉर्मूला, इसको मैं ऑरेंज कलर में हाईलाइट कर रहा हूँ यहाँ, लेट्स से किसी डार्क कलर में कर दें ताकि नजर आए। रेड में हाईलाइट किया इसको। ये फॉर्मूला क्लियर है?
जी सर, समझ में आ गई है। जी सर।
So y, just copy it from here. We know all the values in this formula, so we'll just be writing the answer, which is equal to, just quickly multiply and divide. F1 is 7.85 multiplied by 0.67 plus F2, which is 31.4 multiplied by Y2, which is 2, and then plus F3, which is 39.2 multiplied by 2.33, which is Y3. This comes out to be 159.39. 3955 newtons meter divided by FR, which is 78.5 kilonewtons meter. So by R equals to divided by 78.5, 2.03 meters. 0.03 meters. Clear? Is it clear?
Yes, sir.
Any question in this problem? कोई चीज समझ ना आयु? I believe that it's clear. Okay. So we move on to the next topic, which is hydrostatic force on a curved surface. In the last week, we have been discussing about hydrostatic force on a planar surface. More like the planar surface was like this, and we have been calculating the forces on these planar surface. But in actual applications of the hydrostatics, most of the surfaces are not planar, they are usually curved. For example, if you have a bottle of water, so in most cases it will have a surface like this, right? So it's no more a rectangular surface, it's no more a planar surface, it's a curved surface. The corners are curved. This area is curved. So how to calculate force on a curved surface? Similarly, if we consider the dam wall, in most of the cases, the dam wall is like a curved wall. It's like that. It's not a planar wall or straight wall. It's like that. So how to calculate the force on this dam wall if it is curved? One way is to do in the similar fashion like we have done already. We calculate the formula for FR using a differential point on this curved wall, which we define as dF, force dF, and the area of this differential point as dA, and then we integrate dF. So dF equals to pressure into dA, and we calculate this pressure. But this dA integral will not be that simple for a curved surface. That's going to be too complex for the curved surface. So instead of doing this, what we do, we simplify our problem. What we do is we consider the curved surface as planar surface or its projection as planar projections. What we do is we have, let's say, a curved surface like this, and we are interested in calculating the resultant force or the hydrostatic force FR on this surface. We assume that, we try to understand it with a simple example. Let's say we have a swimming pool, and it is the free surface which I have drawn, free surface of the swimming pool. Instead of being rectangular, swimming pool has a curved surface here like this. So now we are interested in calculating this resultant force. What we can see is that this curved surface has some rectangular projections. Like from this point, below it is the curve is starting, and it is ending at this point. So we have these two rectangular projections here. So we can resolve this resultant force into two components. So what we do is redraw this curved body like this, and we have these two projections here. Sorry for the bad drawing. So we redraw this curved body and we project its rectangular surface like this. So there will be a force on this top projected area, which we label as F2, and we label this as F1. Since this curved surface is interacting with some wall here, which is also curved, so there will be a horizontal component FH of this wall. There will be a vertical component, and then there will be the weight of this fluid, which will be acting downwards to the centroid. क्लियर? ठीक है, समझ आ गई बात?
Yes, sir.
Now we can calculate simply by applying equilibrium that F1, if we write summation Fx equal to 0, with right being positive, so we can write F1 equals to FH, which is basically a hydrostatic force on this projected area, right? On this rectangular or planar projected area. So gamma H C A. We can also write FV if we apply this equilibrium summation Fy equal to 0, and with positive being upwards, we can write Fv equals to F2 plus W, where W can be weight of the body as well as the weight of the fluid. Okay, so that you will resolve into two components, W1 plus W2, depending upon the weight of the gate and the weight of the fluid. And F2 is the force on this projected surface, which is again gamma H into A, plus W being the weight of the fluid plus weight of the gate or weight of the body. ठीक है, समझ आ गई बात? Is it clear?
Yes, sir.
The resultant force Fr would be equal to under root Fh square plus square, and the direction of the resultant force would be, सी डायरेक्शन क्या होगी, स्टैटिक्स में आपने कैलकुलेट किया होगा, Fr would be directed like
theta
this.
is equal to tan inverse Fy over Fx.
Yes, and that theta would be equal to this theta be equal to tan inverse of Fv by Fh. ठीक है? Also the location of F1 and F2. Let's say location of F1 is Y1 and location of F2 is X1, X2. So Y1 would be equal to, and X2 would be equal to what? जी, Y1 क्या होगा? This dimension, which is basically the radius of the semicircle divided by 2. Let's say this dimension is h. So y1 would be equal to h by 2 because we are projecting it as a rectangular surface. So centroid of this projected area. Centroid of this projected area. Similarly, f2 would be centroid of this projected area. If this is r, so x2 would be equal to r by 2. ठीक है, समझ आ गई बात?